Hi, and welcome back. So over the past couple of videos, I have been going through this example with these scales, and really what I was trying to do was just give you an intuition for what significant figures, I guess, are used for and why they're useful. Hopefully you found it useful. If you didn't, please leave me a comment, I guess, and I'll definitely try to improve the videos to try to give you a bit more maybe a bit more intuitive sense of what's why significant figures are used. But anyway, what we're going to do in this video is I'm actually going to give you sort of the concrete rules for dealing with significant figures. So I'll give myself some space. We're going to say sig fig rules. And the first rules that we're going to talk about are just rules for counting how many significant figures that we have. So the first rule is that all non-zero digits, or actually, you know what, I shouldn't say numbers. All non-zero digits are significant. So that means, if we have, let's say, I gave you an example of 23.05670, something like that. We already know, based on this rule, that every non-zero number is significant. Every non-zero number is telling us some information, and hopefully that should be intuitive. That the zero we wouldn't hold a decimal place with a 2 or a 3. We would be holding a decimal place with a 0. So hopefully that's a little bit intuitive for you. The second rule. So the second rule is that the interior zeros are significant. Significant. So that means that these zeros that are in between, or I guess it's just this one zero that's in this example that we have, is saying that this zero is significant because it's in between one significant figure and another. And you could imagine, if, back from our scale example, if we were weighing something, it's very possible that, if I, say I was weighing, I don't know, 23 pounds of apples or whatever I was weighing, it's very possible that one of these digits could be 0, and that's still telling us information about how much those apples weigh. So this interior digit, this interior 0, is going to be significant. The third rule is that trailing zeros are significant. Sorry, I'm still getting used to the pen. Significant. And hopefully you can see, so that means that this 0 at the end, this 0, is also going to be significant. So again, if this was our scale, and it's our scale that, from the past video that gives us 5 decimal places of resolution, or 5 decimal places of information, this last decimal place could be 0. If we didn't know that this number was supposed to be a 0, what would we have written this number as if this last 0 wasn't significant? Well, we just would have written these first 6 digits, right? So if this last 0, if this trailing 0 wasn't significant, we would have just written this number as 23.0567, and we wouldn't have put that 0 on. But because that 0 is there, this trailing 0 is going to be a significant figure. So how many sig figs is going to be in this number we wrote down? Well, we're going to have 1, 2, 3, 4, 5, 6, 7. We're going to have 7 sig figs. So anyway, those are kind of the first 3 rules and sort of an example to point out the first 3 rules. The next rule, let's do another rule. So the next rule, and this is kind of, I'll call this rule 3A. There's no real organization to the rules of significant figures. I guess this is just, actually, you know what, I should call this rule 4. I guess rule 4 is that leading zeros, so leading zeros are not significant. So let's say, as an example, let's say I gave you this number, 0.00057. So what this is saying is that all of these zeros here, and I guess also this 0, that these are all not significant, that all these zeros are doing is holding the decimal place. It's just holding the decimal place for our significant figures. So our significant figures in this example are just going to be our 5 and our 7. So that means in this example we are going to have 2 significant figures. If we put, well, how about if we put 1 0 at the end? Would this 0 be significant or would this be not significant? Well, it would be significant, right? Because it's a trailing 0. So this 0 is significant because it's a trailing 0. These zeros are not significant because they're leading zeros. So anyway, that is, I guess those are most of the rules. Now, one other, I guess, part of the leading zeros, or I guess this is more has to do with the trailing zeros. Let's say I gave you the number 1200, something like that. How much information do we know about this number? And well, I guess I might be leading you in a certain way here by telling you, but it's kind of ambiguous how much information we know, because we could know exactly we could know that, you know, this estimation is exactly where, you know, we have, maybe I have exactly $1,200 in my bank account, and you know, I checked in with my bank this morning. I only ever withdraw in multiples of $20 bills, so I could have exactly $1,200 in my bank account. But then again, I could also say, you know, I don't know, I could say that in this speck of dust I have 1,200 atoms. And that would be, this is more of an estimation. That's not, you know, not an exact figure. So therefore, you know, and I'm just trying to give you a bit of intuition, but this figure is going to be ambiguous. Ambiguous. And I guess if we were going to talk about this being a rule, I'll call this rule 5, that we would say that trailing zeros, if there's no decimal point, trailing zeros if there's no decimal point, like in a figure like this, are going to be ambiguous. So let me write that down. So trailing zeros without a decimal point are ambiguous. And therefore, what we're going to do, and you know, I'll start, I'm running out of time in this video. I'll definitely do more examples about how we would do this in the next video. But what we're going to do, if we had to represent, say we had to represent the number 1200, and let's say we actually, that all of these figures were significant. Let's say we figured out we had, I don't know, we had, you know, 1,200 grams of something, say, and we knew that was correct, and we had 4 significant figures. And at the sort of over the past couple of videos, I've been saying that scientific notation really helps us write out significant figures very effectively. And so that would be the unambiguous way of writing 1200, would be to say that we have 1.200 times 10 raised to the third, right? Because now we've written this out so that every single digit, and that's the important thing about scientific notation, is that every single digit we write out before we multiply times 10 to some power is going to be a significant digit. So therefore, if we knew that we had all four significant figures in our figure for 1200, we would say this is 1.200 times 10 to the third. How about, what would it be like if we only had three significant figures? How would we write this in scientific notation if we only had three significant figures? So actually, I'll just write this down. This is 4 sig figs. So how about if we had 3 sig figs? How would we write down 1200 using scientific notation? Well, we would leave one of these zeros off. So we would say 1.20. So now we've only got 3 significant figures times 10 to the third. We don't have to change the exponent on our 10. All we have to do is just leave one of our zeros off, because you could say that with 3 significant figures, we know a little bit less information about this number 1200 than we did when we had 4 significant figures. So hopefully you can see, and again, it's good to just show yourself that if you were going to multiply these out, these would both look exactly the same. So you wouldn't be able to tell which had 3 significant figures and which had 4 significant figures based on this information. The only real way to tell is when you write it with scientific notation. I guess for that reason, particularly when you're representing numbers like that have trailing decimal places and trailing zeros, and there's no decimal point, it's always good throughout this course, and I'll definitely do this in this playlist and probably remind you of it at different points throughout the playlist. It's always good to write out your answer using scientific notation, and that's I would say, it's maybe it might be a good rule to say that when you use scientific notation to write something out, you could, at least in a general chemistry course, you're never going to be wrong writing out a figure using scientific notation, because it's the least ambiguous way of displaying how many significant figures you have. Well, anyway, I'm out of time in this video. In the next video, we're going to talk about how you carry significant figures through different operations, and I guess that is really that can really be one of the most confusing parts of dealing with significant figures. So anyway, thanks for watching, and I'll see you in the next video.